would say still stands unless they tell you to use the natural, like if they say, if they set up the formula and have base E in it, or if they say it grows continuously. That word continuous growth, that's the base E growth. Because it didn't say grows continuously, I wouldn't use the base E, right? And I sort of said that again. So do you remember what we did last year or yesterday? It said a city has a population of 150. It decreases by 8%. How many years will it take for population to become 50? So this is how I did it in class. I'll just reiterate what I did. I went 50,000. Whoops. 50,000 equals 150,000. Okay, so I'm using this form, right? A equals P, then my base, whatever my base is, and I'll use T for number of years, right? Okay. And then here, and I'm solving for T. If they decrease by 8%, that means my growth rate is actually only 92%, right? If my growth rate was 100%, I would just keep retaining the same number of people a year, right? If my growth rate was 110%, this number inside is 1.10, like we said yesterday, and it's a positive growth rate, so it's growing. This just indicates my population's declining, right? And this way, when we did it, we solved, we actually got whatever they said in the back, right? Which was 7.7, number 3, which is about 13.2 years. I think it was 1.7, something like that, wasn't it? So I actually did this one yesterday, and that's how they did it in class, in the book. And why they did it this way is because it didn't say continuous growth. Now, some of you did it this way, though. Some of you flipped back, and which is what I told you to do. You flipped back and you found, where was it again? You used this formula, right? Okay, so I'm going to record that. You used y equals NE to the k times t. Right? And the only thing I would do here is I'll just replace these with A and P, because we know those are final and initial, right? So I'll use A and P. When you use this, your growth rate, here your growth rate is the base of an exponential function. Here your growth rate in this form, when your base is E, you use the rate, the growth or decay rate as an exponent. So that changes things. Let's look back to this page. The general form for growth and decay in nature is an exponential function. Y is final, N is initial, K is a constant. Okay, this is important. K is positive for growth and negative for decay. Okay, so you have to remember that. E is your number in the calculator and T is time. Okay, this means K is positive for growth. K is negative for decay. Okay, so here this one was growing, increasing, so K is a positive number. I don't think they did one for decay, okay? But our population was decreasing, right? So if you want to do this way, and I think many of you did this, then you use your E. This is where you actually use the decay rate they give you. So this is going to be negative 0.8 T. And then I think when you do this way, which is what you did, Joanna, right? Didn't you? And then you actually end up, it's slightly off, right? But it's close, but it's off. So what I would do here is, I'll just do this quickly. It was 1/3, right? So we'd have ln of 1/3 equals negative 0.08 ln of E T, right? And then the ln of E cancels. So then I divide through by negative 0.08, and that's going to be equal to my T. So here we get this ln of 1/3 1 divided by 3, okay? I'll just go equals, divided by negative 0.08, and we get t equals 13.73 years. Okay, and that would be acceptable, 13.73 years. They used this formula, they got 13.17. If you use this formula, you got 13.73. You did everything correctly, right? You're just a bit off because it wasn't, they didn't say the word natural growth, they didn't say continuous growth, okay? Either way is fine, but notice the differences. Here, the base is whatever the population's actually growing at. If it's decreasing, it's going to be growing at a 0.92 rate. Here, the rate, you actually use the number they give you in the exponent. So if it's decaying at 8%, you use that as an exponent, but just make sure decay is just with a negative. If it was growing at 10%, it would be positive 0.10 t. So either of these are fine, right? But just continuous growth is usually the we use the E with. Okay. Was there anything else so far in the word problems that you were stuck with, or no? Okay, so continue on. How about questions without calculator? Anything that you're stuck with? Remember, you guys are writing the test Monday, so get things cleared up if you need. Rahel? 13 on this one? Okay. Let's see. I think I did this one already. I'll erase it and do it again. Okay, let's take a look at number 13. Now, the nice thing about this, it's multiple choice, so you know all the answers are represented somewhere. You just have to pick the right one, right? Solve for W. Log of 4W plus 3 minus log of W is log of 10. Okay, I have the same base, right, Rahel? All three logs share the same base 10. Okay, so I'm going to put these two together. So that would be log of 4W plus 3 divided by W, and that equals log of 10. Now, same base, I can cancel the bases out and just make the arguments equal to each other. So 4W plus 3 over W equals 10. Sorry? Oh yeah, I could put the 1 there too, I suppose, right? But if there's a base and a base though, if I'm just canceling out the base, I could also say that, can't I? You know what I mean? Okay, let's see. 4W plus 3 equals 10W. 3 equals 6W. W equals 3 over 6, or W equals a half. So I'd say the answer is A. Is that what the answer is? 13A. I think if you did it that way, it should still work, John. Or did you? Let's see. Questions without a calculator. The answer is A, though. Okay, let's see if your way works. It should work. Okay, let's see if John's way works. So we've got log, I've got this, log of 4W plus 3 over W equals log of 10. And John's right, log of 10 equals 1, right? So if I just call that 1, I'll have log of 4W plus 3 over W equals 1. And now with your way, I can't do same base, but I can put an exponential form, right? So 10 to the power 1 equals 4W plus 3 over W. Can you see we're at the same stage that I was here now? So now I'm going to cross multiply. 10W equals 4W plus 3. 6W equals 3. W equals a half. 3 over 6, which is a half. You should still get the same answer. Anything else so far? Yeah.
7.
On that same assignment?
Yeah.
Okay, we've talked about that one a couple times with a few people. That's a very strange one, right? Those words, I'm just going to erase my work. I have actually that one double starred because it was so strange. But it's doable, right? You have the skills to do that one, but you got to take it slow. Okay, 1 centillion. Had anyone ever heard of 1 centillion before? I hadn't either, to be honest, before this. 1 centillion is defined as the 100th power of 1 million. What is log and base 10? And this was the hard part, right? I think John and I talked about that. It doesn't really look like a subscript, right? But it's log and base 10 of 1 centillion. I don't know why they put that 10 there because it's not really necessary, is it? Okay, so if this is what 1 centillion is, they're asking us what log and base 10 of 1 million to the power of 100. The 100th power of 1 million. Okay, so they're asking me, what does this all equal? So that's what I'm kind of trying to find here, right? So I put it in, I guess, exponential form, right? So 10 to the power x equals 1 million to the power of 100. Okay, well this is just an exponential equation then, right? So I have 10 to the x equals, well what would this be written as a base 10 number? Just count the number of zeros and that's what your power is, right? And then I still have this power of 100. So that must mean x must equal 600, which is D. I think you just needed the courage to move forward and like to write something down on the paper and just start that question, right? Once you start the question, then it becomes a little more obvious, but that was a strange one, right? '26. Let's take a look at 26. Ooh, I didn't even get this far. Let's see this one. If x equals b to the power of c log b d, then which of the following must be true? And I think they were going back to I think they might have used this rule, Joanna. I think they gave you a hint somewhere. Where was it? Let me just find it. Okay, if you look back on page 242, this number 7, n of log n x equals x. Okay, so if the base and if these two bases agree, then this whole thing simplifies just to x, the exponent. Yeah, so let's see what that means. So let's look at this. If I rewrite this as x equals b log b to the base d, I'm going to write that c up as another exponent though, right? I'm going to remove it as the coefficient. Okay, so that rule we just read is if this base and this base equals, they kind of cancel each other out, and I'm left with dc. So I think it's x equals d to the power c. Hi, Eduardo. Yeah. And you could probably do it another way by taking logs of both sides again and like logging twice and then bringing that down. You might be able to do it another way too. Okay. All right. Any other immediate questions or till I give you a little more time to work? Okay. Do a little bit of work and then I'm gonna, I might challenge you to do a few other questions for me today, not off the page. So If you're done everything, let me know.